Hello guys, in this video we are going to discuss the solution of the problem minimize the height 1. So let us look at the problem statement. The problem statement says given a positive integer k and an array ARR denoting the heights of the tower, you have to modify the height of each tower by either increasing or decreasing them by k only once. Find out what could be the possible minimum difference of the height of shortest and longest towers after you have modified each tower. So for instance, if this is the height of the tower which is given to us, the array can be modified in this way, and after that modification, if we compute the difference between the largest and the smallest tower, we will get 8 minus 3 which is equals to 5, and that is what we are returning over here. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is, first we are going to sort the array. And the reason we are sorting the array is because we want to minimize our computation. And the computation which we are talking over here is to compute the difference between the height of the shortest and largest tower. So in order to minimize that computation, we are going to sort the array. Now we want to compute the difference between the height of the tower. So let us say initially the height of the tower was given by A and B. So over here A is less than B. So A is the smallest tower and B is the largest tower. And with these two towers, we have an option to either increase or decrease the height of each of the tower. Now it turns out that by increasing the height of tower A by k and decreasing the height of tower B by k, we will be able to minimize the difference between the height of the tower. Because of which the computation which we are interested is, we are going to increase the height of tower A, so A becomes A plus k and B becomes B minus k. Again, we are going to discuss these things, that why are we increasing the height of tower A and why are we decreasing height of tower B. But for now, let us proceed forward. So now we have the array sorted in ascending order with this step, and we also know that if we want to minimize the difference between the height of the tower, then we have to increase the height of tower A by k and decrease the height of tower B by k. With this, what we are going to do is, we are going to compute the height of the shortest tower, and then we are going to compute the height of the largest tower. So this essentially over here, this is my tower B. So you can think this as B from this example, and this is my A. So as you can see, I'm increasing height of tower A by k and I'm decreasing height of tower B by k. And then we are computing the difference between the tallest and the smallest tower, and we are comparing it with our answer. If this is the minimum, then our answer will be updated as such, and towards the end we are going to return our answer. So that's the general and brief idea about solving this problem, folks. Now let us discuss each of these steps in more detail. So in order to discuss that, let us take an example. So let us say this is the height of the towers which is given to us. Now if we don't sort the array and if we want to compute the difference between height of the towers, then what we have to do is we have to compute the difference between all the towers. So what do I mean by this is, we need to compute the difference between 8 and 5. We need to compute the difference between 8 and 1. And then we need to compute the difference between 8 and 10. Similarly, we also have to compute the difference between 5 and 1, 5 and 10, and then 1 comma 10. So these are the different pairs which are possible over here, and since the array is not sorted, because of which we need to compute the difference between all the pairs. Now let us say the array is sorted. Now if the array is sorted, then the array will look something like this, and the different pairs will look something like this. Now folks, as we can see that the number of pairs remains the same, but here comes the optimization. Please note folks, over here we wanted to minimize the difference between the heights of the towers. So if you compute this difference, the difference between the height of the tower, this is 4. And if you compute this difference, this is 7. And similarly this is 9. Now since the array is sorted, because of which the minimum difference between the height of the tower will be given by this pair. On this layer will give us the height which is greater than the first one. So because of which we are going to discard these pairs. Similarly, when we are in the next row, then we just have to compute the difference between this pair and we can safely discard this pair. Similarly, on this layer, we are just going to compute the difference between this pair. So in a sense, since the array is sorted, we don't really have to compute the difference between all the pairs. Rather than that, we just have to compute the difference between this group. And if you look carefully, this group is essentially the difference between the consecutive element. So 1 minus 5, 5 minus 8 and 8 minus 10. And this is the reason, folks, why we are sorting the array. So with sorting, we will be able to minimize the computation. So that's about the first part, folks, over here. Now let us discuss why a comma b has to be transformed to a plus b comma b minus k. So to discuss that, let us take that we are investigating a pair a comma b. Now with a and b we have two options, which is either to increase a by k or decrease a by k. Similarly, increase b by k or decrease b by k. So let us investigate all these four combinations. So the first combination we will get is, let us say we want to increase the height of both the towers. So a becomes a plus k and b becomes b plus k. Similarly, the second combination we will get is, we can decrease both the heights by k. So a becomes a minus k and b becomes b minus k. Third, we can increase the height of tower a by k and decrease the height of tower b by k. And the fourth option, which is the last option, decrease height of tower a by k and increase the height of tower b by k. Now with these pairs, let us compute the difference between the height of tower a and b. So if we compute the difference between height of tower a and b, this will be given by b plus k minus a minus k, which is essentially equals to b minus a. Similarly, in this case, this will be equals to b minus k minus a plus k, which is equals to b minus a. Over here, this will becomes b minus k minus a minus k, which is equals to b minus a minus 2k. And last, this will become equals to b plus k minus a plus k. So this becomes equals to b minus a plus 2k. So the resultant values which we are obtaining over here is b minus a. So in these two cases, the difference between the height of the towers remain unchanged. So we are going to discard these two things. And with the fourth one, the difference between the height of the tower gets increased by 2k. So again, we are going to discard this one. And as you can see, with this combination, we are able to decrease the difference between the height of the tower. Because of which, if we want to minimize the difference between the height of the tower, then a comma b has to be transformed to a plus k and b minus k. And folks, with this, I hope this is clear why a comma b has to be transformed to a plus k comma b minus k. Now let us discuss the final case, which is how do we compute the height of the shortest tower and height of the largest tower. So let us discuss that case. So to discuss that, let us say we are operating on ARR I minus 1 comma ARR I. So two adjacent element, let's say any ith element, and we are operating on I minus 1th element and ith element. And then we want to find out what should be the height of the shortest tower and what should be the height of the longest tower. Please note, folks, over here till this point we have already sorted the array. So let us discuss this. So for that, let us say this is the array which is given to us, and the array is already sorted, and let's say the elements of the array is A, B, C and D, some arbitrary elements. So the height of the shortest tower will be given by essentially minimum of, and within this array, what is the smallest tower which we have? Well, the shortest tower we have is the first tower whose height is given by A. So the minimum of A. Similarly, the height of the longest tower will be given by max of, and in this array, what is the length of the longest tower? Well, the length of the longest tower will be given by D. Now, as we know, we need to manipulate the height of the towers. And from our step 2 logic, we know that in order to minimize the difference between the height of the tower, the shortest tower height has to be increased by k. So we are going to increase this height by k, and we are going to decrease the height of the tallest tower by k. So this A becomes A plus K and D becomes D minus K. Now we are operating on I minus 1 and ith tower. So again in I minus 1 and ith tower, I minus 1 is the smallest tower and I is the longest tower. And let us say we are operating on the pair B comma C. So as we know, this has to be transformed such that B becomes B plus K and C becomes C minus K. Now when we alter the height of tower B to B plus K, then it might be possible that this becomes the tallest tower, because of which B plus K has to be compared with D minus K in order to determine the height of the longest tower. So when we are computing the height of the longest tower, then what we have to do is we need to compute the length of D minus K with B plus K. So let us compute this. Similarly, when C becomes C minus K, then it might be possible that this becomes the smallest tower or this becomes the shortest tower, because of which when we are computing the height of the shortest tower, we need to compare A plus K with C minus K in order to compute the height of the shortest tower. And in this way, folks, we will be able to compute the height of shortest and longest tower, and towards the end, in order to get to our answer, all you have to do is we just have to compute the difference between shortest and longest tower. So let us say this is given by S and this is given by L. So in order to compute our answer, all we have to do is we need to compute minimum of answer comma L minus S. So whatever is the minimum between these two will be our answer. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let's say we want to compute the minimum diff and an array is given to us. So for this, as we have discussed, the first thing which we are going to do is we are going to sort the array. Once we have sorted the array, then let us set the initial value for answer. So the initial value of answer will be given by ARR n minus 1 minus ARR 0, essentially the difference between the last element and the first element. And let's also have n set, so n will be equals to length of array. After this, we are going to iterate on the elements of the array. So for I in range of 1 to n, and let us compute the height of the smallest tower. So S will be equals to minimum of ARR 0 plus K ARR I minus K. Similarly, the height of the largest tower will be given by max of ARR n minus 1 minus K, comma ARR I minus 1 plus K. And once we have computed the height of the smallest and largest tower, all we have to do is we have to update our answer by answer equals to minimum of answer comma L minus S, and towards the end we just have to return answer. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. So in the Python implementation, n is equals to length of array, then we are sorting the array, and then we are setting answer equals to the difference between the height of last and first tower, and then we are computing L and M, and then answer is equals to minimum of answer comma M minus L, and towards the end we are returning answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. N equals to size of the array, and we have sorted the array. Then answer equals to the difference between last and first element of the array. Then we are computing the height of shortest and largest tower, and then we are computing our answer, which is equals to minimum of answer comma temp max minus temp mean, and towards the end we are returning answer. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ solution also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.